Hi guys, this is AS Chemistry using Avogadro's constant. Question 1. What is the number of molecules in 500 cm cube of oxygen under room conditions? So we know that 1 mole of any gas under room conditions occupies a volume of 24 dm cube. When converted into cm cube, that becomes 24,000 cm cube. So we calculate the number of moles, which would be 500 divided by 24,000. This would give us a value of 0.02083 moles. And now we need to find out the number of molecules of oxygen. So number of molecules in 1 mole of oxygen would be equal to the Avogadro's constant, which is 6.02 into 10 to the power of 23. Therefore, the number of molecules of oxygen in 0.02083 moles of gas that we have would be 0.02083 multiplied by 6.02 into 10 to the power of 23, giving us a value of 1.25 into 10 to the power of 22 molecules, which makes option A the correct option for this question. Question 2. When a sports medal with a total surface area of 150 centimeters square was evenly coated with silver using electrolysis, its mass increased by 0.216 grams. How many atoms of silver were deposited per centimeter square on the surface of the medal? So the first thing we need to do is find out the number of moles of silver deposited. So that would be the mass of silver, which is 0.216 grams divided by its AR value, which is 107.9. This gives us a value of 0.002 moles. So now we know the moles of silver that was deposited. So the number of atoms of silver deposited would be 0.002 into 6.02 into 10 to the power of 23, which would give us a value of 1.204 into 10 to the power of 21 atoms. So these are the number of atoms deposited on a sports medal with a surface of 150 centimeters square. And they've asked us to find out the number of atoms deposited per centimeter square. So the next step would be to divide 1.204 into 10 to the power of 21 by 150 in order to obtain the number of atoms present per centimeter square of the medal. So this will give us a value of 8.03 into 10 to the power of 18 atoms per centimeter square of the medal. So this makes option A the correct option for this question. Question 3. Nickel makes up 20% of the total mass of a coin. The coin has a mass of 10 grams. How many nickel atoms are in the coin? So first we need to find out the amount of nickel that is present in a 10-gram coin. So that would be 20 upon 100 into 10, giving us a value of 2 grams of nickel present on the coin. The next step would be to divide 2 grams by 58.7, which is the AR of nickel, to obtain the number of moles of nickel, which would give us a value of 0.0341 moles of nickel present. And the next step would be to multiply 0.0341 into 6.02 into 10 to the power of 23, which would give us a value of the number of nickel atoms present on the coin. So this gives us a value of 2.05 into 10 to the power of 22 atoms, making option A the correct option for this question. Question 4. which would contain 9.03 into 10 to the power 23 oxygen atoms. So the given options have different compounds in them. So first, let's write down the formula of the compounds. For option A, we've got aluminum oxide, which would be Al2O3. For option B, it's sulfur dioxide, which is SO2. For C, it is sulfur trioxide, which is SO3. And for D, it is water, which is H2O. So in option A, we've got three atoms of oxygen present, and the mole of aluminum oxide is 0.25. So this would be 0.25 into 3, which would give us the moles of oxygen atoms present. For option B, it would be 0.75 into 2. For option C, it would be 1.5 into 3. And for option D, it would be 3.0 into 1. So this will give us the number of moles of oxygen present in each of these compounds. Then we multiply each of these numbers by 6.02 into 10 to the power of 23 to obtain the number of oxygen atoms present in the compound. So all of these would be multiplied by the Avogadro's constant to obtain the number of oxygen atoms present. So this gives us values of, for option A, 4.5 to 10 power 23. For option B, the value is 9.03 into 10 to the power of 23. For option C, the value is 2.71 into 10 to the power of 24. And for option D, it is 1.81 into 10 to the power of 24. So the value that we needed was 9.03 10 power 23, which we have obtained in option B, making option B the correct option for this question. Question 5. Diamond is a pure form of carbon. The mass of a diamond can be measured in carats. 1 carat is 0.200 grams of carbon. Which expression gives the number of carats that contains 6.02 into 10 to the power 23 carbon atoms? So we need to remember 6.02 10 to the power of 23 is the Avogadro's constant, and this is the number of carbon atoms present in 1 mole of carbon. And the AR for 1 mole of carbon is 12. So what we end up with here is that 0.2 grams of carbon is the amount of carbon present in 1 carat. So how many carats would be present in 1 mole of carbon, which is 12 grams? So this will calculate to 12 upon 0.2. So 12 upon 0.2 is the correct formula present in option C, making C the correct option for this question. Question 6. A sample of solid ammonium chloride decomposes on heating and it produces ammonia gas, which is NH3, and it produces hydrogen chloride gas, which is HCl. So the question says a total of 2.4 into 10 to the power 21 molecules of gas is formed. How many hydrogen atoms are present in the gaseous products? So if the total moles of gas formed would be 1 mole of ammonia and 1 mole of HCl, so 2.4 10 power 21 molecules are present in 2 moles of gas produced, and they're asking number of hydrogen atoms. So how many molecules would be present in the number of moles of hydrogen atoms? So which would be 3 hydrogen atoms in ammonia and 1 hydrogen atom in HCl. So in total, 4 moles of hydrogen atoms. So this would give us a calculation of 4 upon 2 into 2.41, no, 2.4 into 10 to the power of 21. So this gives us a value of 4.8 into 10 to the power of 21 hydrogen atoms present in the given sample of gas or other gases. So this makes option C the correct option for this question. Question 7. Analytical chemists can detect very small amounts of amino acids down to 3 into 10 to the power of minus 21 moles. How many molecules of an amino acid having an MR of 200 would this be? So we know that 1 mole would contain 6.02 into 10 to the power of 23 molecules. So the number of moles given is 3 into 10 to the power of minus 21. So this would contain how many molecules of amino acids? So this would be 3 into 10 to the power of minus 21 upon 1 into 6.02 into 10 to the power of 23, giving us the number of molecules of amino acids to be 1806. So according to the calculated value, the correct option for this question is option C.